Okay, so now let's take several minutes and review the remaining modules in OSForensics. The Clipboard Viewer allows the investigator to browse the contents stored in the clipboard on the live system, which can contain forensic artifacts of interest such as possible passwords, image files, and contraband files. In newer versions of Windows, a clipboard history is available which can provide up to as many as 25 items that have been previously added to the clipboard by the user. In addition, if an item has been pinned to the clipboard by the user, the data will persist on disk even on reboot or shutdown. However, this pinned data is unfortunately encrypted. Here's a look at the settings page for the Clipboard History feature, which was first introduced in Windows 10 build 17666. On a live system, you can manually access this Clipboard History feature by pressing the Windows key plus the letter V on the keyboard. This will display the stored clipboard contents since the last machine boot. This is still volatile, but in situations where a machine has been running for several days, you may find quite a bit of data here. Users can choose to pin an item in the clipboard history by clicking on the push pin icon next to the item as shown here in this slide. As mentioned before, this pin data is actually written to the disk, but encrypted. Here is the storage path for the pinned data. In this slide, we see an example of a possible complex password that a user has copied to the clipboard. Adding clipboard data to your case is simple. Just click the Add List to Case button to add the clipboard data to your case. Next, we'll look at the Event Log Viewer. This new module allows users to view and examine event logs created by Windows. It supports event logs with the common file extension .evtx that are located in the System32 WinEVT logs directory. To use the viewer, choose the appropriate source drive, then click the Scan Drive button to locate all available event logs on the source device. When the scan completes, you can then navigate the event log directories in the left-hand tree pane view. To view list of logs in the event log file, click one item on the left-hand pane. After then, you can perform sorting and filtering of the results under the main event logs tab as shown here in this slide. If you click one log item from the list, the General tab at the bottom will show the detailed properties of the selected log. Shifting to the Details tab allows you to view the XML information of the event. You also have some extensive filtering presets to help get you to the logs you are interested in. Directly next to this, you will see a quick filter string search box that is also available. If you need more filtering options, click on the Advanced Filter button to bring up the Filter Results window. You will then add filters by selecting different filter conditions. Once you've selected the conditions, click Add Filter to add the filter to the Filters List view. These filters are also able to be exported to a file and then imported as required. Here we see the device connected preset filtering logs from the Microsoft Windows Partition Diagnostic event log. Starting in Windows 10, these logs are created whenever a user connects or disconnects a removable device from the system. These are great artifacts to review if you need to create a timeline of connection and disconnection, date and times of a particular device or devices. To add event log artifacts to your case, simply check mark the artifacts you wish to include and choose the Add to Case option from the right-click menu. You can also view results in a timeline format by clicking the Timeline tab. You can then choose a year, a month, a day, or time, and show only the artifacts in that particular time set through the right-click menu. This is a great example of how you can use filtering in our Timeline View feature to quickly cull down a large amount of data to just the relevant artifacts you are looking for. Here's an example of using the Quick Filter option to locate only records containing a specified keyword. In this example, we can see a SanDisk Ultra USB 3.0 with the serial number shown was connected to the system on December 3rd, 2019 at 11:11 hours. Okay, so moving on to the USN Journal Viewer. The USN Journal Viewer in OSForensics takes much of the difficulty out of analyzing this very important but often overlooked forensic artifact. The USN Journal, which stands for the Update Sequence Number Journal, or Change Journal, is a feature of NTFS which maintains a record of all changes made to the volume. One journal is maintained for each NTFS volume and stored in the NTFS metafile named $extend/$USN-JRNL. It begins as an empty file. Whenever a change is made to a volume, a record is added to the file. Each record in the change journal contains the USN, the name of the file, and information about what the change was. The change journal describes the changes that took place using flags, such as overwrite. Therefore, it does not include all the data or details associated with the change. For this reason, the change journal cannot be used to undo operation on files within NTFS. The USN journal is used by the File History feature introduced in Windows 8 to determine which files have changed since the last backup so that only files that have changed are added to the history. USN journals store changes to the volume usually up to a week, though maybe shorter. USN journal logs reside on external disks as well, and much of the random data located in an allocated space on a disk has been found to come from older change journals. When you click on the USN Journal Viewer, OSForensics will attempt to automatically locate the USN journal for you. Simply highlight the journal file and click Open. OSForensics will then begin parsing the journal data and takes an additional step of cross-referencing the USN journal with the master file table, or MFT. We use the MFT number instead of the parent MFT number, so if the file was renamed, moved, or deleted, you will see a path that is inconsistent with the file name stored in the USN record. Here we see the string searching capabilities within this module. This is a very quick and painless way to try finding remnants of files that are no longer on the file system or even unallocated space. In addition to locating file info of interest, you can also get an idea of the change that occurred to that file by reviewing the reason column in the USN number timestamp. It should be noted that the journal records do not indicate how the file contents have changed, rather whether it has been created, modified, overwritten, or deleted. The OSForensics plist viewer allows you to view the contents of plist or property list files, which are commonly used by OS X and iOS to store relevant settings and properties. plist files typically have the extension of .plist. The plist viewer within OSForensics is able to display both binary and XML formatted plist files. Here we see some examples of plist files and why they might be relevant in a case involving a Mac. In this slide we see an individual plist file in the plist viewer. OSForensics gives you the ability not only to add the plist file itself to the case, but you can also checkmark and add only the relevant data inside of a plist file to your case as evidence, as shown here in this example. The ESE Database Viewer provides visibility into databases stored in the Extensible Search Engine, or ESE, file format. The ESE database format in particular is used by several Microsoft applications that store data with potential forensics value, including the following: the Windows Desktop Search, Windows Mail, Microsoft Exchange Server, and SRUM. Once opened, a list of known database files are displayed for the selected device. Alternatively, the database file can be manually selected by clicking the Browse button and locating the file itself. When attempting to open a file with a known ESE database file extension using the OSForensics file viewer, the user may be given the option to open the file using the ESE database viewer instead. Once the database file is opened in the viewer, the tables list is populated with the tables contained inside of the database. The two major tables in the windows.edb file are highlighted in red as you see here in this example. The windows.edb database is the Windows Search Indexer service. So keep in mind this database is also parsed and categorized in the User Activity module under the Windows Search category. However, there is much more metadata type of information contained in the database file that you can view in the ESE database viewer. To view the records contained in a particular table, simply select a table from the tables list. You can also perform string searching functions in the search box. For some known tables, only a subset of the most common columns are displayed, due to having a large number of columns. This message is shown on the bottom of the viewer. Clicking on the message allows for selecting the columns to display. The email viewer provides a simple yet powerful interface for browsing and analyzing email messages across multiple email files. The email viewer supports PST, OST, MSG, Inbox, DBX, and EML file formats at this time. The left pane provides a hierarchical view of all devices added to the case. Clicking on a node shall load its contents into the right pane. The default view setting is HTML/rich text format, which does not show the email header information. To review the full header info, simply click the View button and choose Headers as shown here in this example. Users have string searching, regular expressions, and date range options when searching emails. To add emails to your case, simply check mark the email or emails you wish to add, right-click and choose the Add to Case option. You can also export emails as individual MSG files, HTML, or PDF files via the right-click menu as shown here in this slide. This is a fantastic feature and very simple for e-discovery cases and investigations involving email. The Thumbcache Viewer is another valuable tool in OSForensics suite of viewers for locating artifacts of graphic image files that may have been deleted on the system. In particular, the Thumbcache Viewer allows the investigator to browse image thumbnails stored in the Windows Thumbnail Cache database. When a user opens Windows Explorer to browse contents of folders, Windows automatically saves the thumbnail of that file in the Thumbnail Cache database for quick viewing at a later time. This can be useful for forensics purposes, especially for cases where certain image files are important, and especially when these images have been deleted by the user and are unrecoverable, as the thumbnail of that image still remains in the Thumbcache database. When a source drive is selected, simply click the Scan button. OSF in just a few seconds will find all Thumbcache files on that drive, disk image, and present them for viewing. Simply select one from the list and choose Open. The selected Thumbcache database opens by default in List View. Selecting one of the thumbnails opens the image in the Preview pane as shown here. It is often easier to review the data in the thumbnail view as opposed to the list view, as shown here. Simply click the Thumbnail View tab to review the thumbnails in this manner. The Thumbnail Viewer supports many different types of thumbnail files as used by Windows over the years. This slide shows many of those supported types. Thumbnail caches by itself do not contain any file path information about the individual thumbnail entries. However, it does include a hash for each thumbnail entry that can be mapped to its corresponding file path. This file path mapping can be found in the Windows Search database. To perform a file path lookup, simply click on the Load ESE Database button as shown on this slide and choose your windows.edb file and click OK. By performing a file path lookup, the Thumbcache viewer can automatically try to find the matching file path in the Windows Search database. The corresponding file path is then displayed beside the thumbnail entry in the table. Users can add an individual thumbnail or a group of thumbnails to the case simply by check marking them and choosing Add to Case from the right-click menu as shown here. Okay, let's pause here and take a moment to do a practical exercise with the Thumbcache viewer. Open the Thumbcache viewer, browse to the sample Thumbcache databases in the student image. Review results and add some of these items to your case. OSForensics provides a tool to find changes in files and directories between two shadow copies from a single volume. By comparing the signatures between two shadow copies, files that have been created, deleted, or modified can be determined within the period of when the snapshots were taken. In order to use our volume shadow copy analysis feature, you must first add a source disk to your case, such as through the drive letter, physical disk, or image file options. Once the source drive has been added, users will go back into the Add Device module and choose the Volume Shadow Copy option. You will then be able to see any and all available shadow copies to add to the case from that source drive. Users can choose to add all volume shadow copies of the case or choose individual shadow copies to add to the case. Once added to the case, OSF will treat each shadow copy as a separate device inside the case, meaning you can also run many of the other automated scans that we've talked about in the course against that shadow copy. Shadow copies are stored by Windows in the System Volume Information directory located at the root of the C drive. The shadow copies are labeled in OSForensics by their shadow copy ID, which is how Windows views them. The shadow copy ID is a globally unique identifier, or GUID, which is not the same as the shadow copy's file name as found in the System Volume Information directory. Here's a look at the Analyze Shadow Copies module. You will see the base volume, which designates which volume contains the shadow copies to be analyzed, plus the new and old volume selections. Once the newer and older shadow copy have been selected, the user simply needs to click the Analyze button, at which point OSF will compare both signatures for all differences between the two. Results can be filtered by new, deleted, or modified, and the columns are also sortable. You will notice many similarities between this module and the Compare Signatures module. From the results, users can create a hash set, export results, and add items to their case. For a short video tutorial on the shadow copy analysis features, please visit our YouTube channel at this time at the link displayed here. The Web Server Log Viewer allows users to extract and analyze log data generated by Apache, IIS, and other custom web server logs. The viewer supports common, combined, and custom log formats, supports IIS W3C Extended, IIS, NCSA log file formats, supports IPv4 and IPv6, and you can export to CVS, TXT, or HTML. To add log files, select a file to open by clicking Add Log File from the top menu or the Image button on the main menu. Then the user will be prompted to select log file options. The user will need to specify the log format of access log, error log, IIS log, or custom logs. Here are some commonly used access log format strings supported by Web Server Log Viewer. Here are some commonly used error log format strings supported by the Web Server Log Viewer. Select the Custom Log option when loading log files with customized log fields. Choose the fields and add them to the list in order. Many of the options available in the right-click menu are standard across all features within the tool. That being said, it should be noted there are several useful and feature-specific right-click options available in the Web Server Log Viewer, such as those highlighted here in this slide. To support workflow automation of common or complex forensics tasks, scripts can be developed and executed in the script player to automate OSForensics discovery and analysis tasks. By developing and maintaining scripts as part of the forensics workflow, standard tasks and procedures can be repeated by any investigator in order to boost efficiency, minimize human error, and reduce training costs. Scripts are written using the Python language and can access OSForensics via the OSForensics Python API implemented as a Python module. To start developing scripts, click on the New Script icon to open a new tab with a blank script template, or click on the drop-down button to select a built-in template script. The built-in template scripts provide a starting point for using OSForensics Python API, which can be extended to building more sophisticated scripts. An existing script can also be opened by clicking on the Open Script icon. As we just stated, scripts are written in the Python language which access the OSForensics functionality via the provided Python module. This module defines a list of methods that allows forensic tasks to be performed without needing to manually perform the operation using the graphical user interface. These methods can be called within your scripts, allowing the return data to be manipulated further by importing built-in or third-party Python packages. For example, Python AI packages can be used to train image recognition models using the images returned from an OSForensics file search. Once the script is ready to be executed, click on the Run Script icon. The output of the script execution, including syntax errors, is shown in the output window. To export or save the output to the case, click on the Export to File or Add to Case icons. You can also install third-party Python packages via a Python Package Manager. Click on the package icon to open the Package Manager. To search or install a Python package, enter the partial name of the package and click Search. Right-click the desired package and select Install Package. You can also remove or upgrade a package just by right-clicking the package under Installed Packages and select Remove Package or Upgrade Package.